in the containerization space. I just don't work for Docker anymore. I'm not a software engineer, but I do code, and I have contributed to a lot of upstream open source projects. My role is really going to help customers, and now more about enabling internal teams to go out and help customers modernize their software deployment practices, modernize their application architectures, and kind of realize business value, I guess. That's a bit hand wavy, but we work with very small customers, 20, 30 people, up to customers with like 500, 600,000 employees. So all kinds, IT companies, all kinds of companies. So let me share my screen here. And you should be able to see VS Code. You can't shout. All right, so I probably have like 20 minutes worth of stuff. I don't have any slides or anything, but I might draw some diagrams. And there's a couple of things I just wanted to talk through to kind of explain what Docker is and why it's useful and why you might want to look into it and why you might want to use it, and then where you might want to go after that. And then I'm happy to answer questions either about Docker or about, I don't know, industry in general. I've been around a while, so cool. So I guess the best way to understand what Docker is to try and understand the problems it tries to solve. And I realize that there's a varying kind of degree of different levels of experience. Some folks have done some computing before, maybe they've done a degree, they've worked in the industry a little bit, or some folks coming to it as a completely new career change. Like a career pivot. So I know you've been working on backend stuff. Last month was Node, introduction to Node and backend stuff. And this is like a lot of database stuff this week, I guess, and authentication next week. So one of the things you might have noticed when you work in JavaScript, a lot of dependencies, right? You pull in your package.json, you got to install, first of all, you got to install Node, right? That's already on your machine. Then you got to install NPM. You might have to install Yarn, depending on how you manage dependencies. You got all these libraries, especially the Node ecosystem, JavaScript ecosystem. I won't say fragmented because that kind of has a negative connotation, but there are lots of dependencies, lots of little libraries you can pull in to do lots of different little things. And every other language is very similar, right? If you were using Python, I know you do that later on in labs, Java, every library leans heavily on an ecosystem of libraries. Every application of a non-trivial size is going to have a huge number of dependencies you need to pull in. So when I run this application on a server, right? So right now you're just running on your machines, or you pushed it out to Heroku, they're running on a server. When I'm running this in an enterprise environment, I would have a server somewhere, just a computer, right, that someone owns. And I want to install my application on it. So I got to install Node, I got to install all these libraries, then I got to run my application, I got to make it available to the outside world. Now, I don't want to have one application per server, because for efficiency, servers are pretty big, right? So if I want to run multiple versions of the application, what about if they have different versions of dependencies, right? So I got maybe development team A is working on a front-end application to do X, and they need Node version 10.2, and this version of certain libraries, Axios, this version, that version. And then I have another development team that might be working on some backend component that needs a different version of Node and a different version of a library for some other reason. I got potential for these dependencies to clash with each other, and I got to be very careful how I manage that server, right? And how I upgrade those dependencies. Let's say security flaws maybe come out. I need to upgrade certain dependencies or certain runtimes. Yeah, I need to upgrade Node, or I need to upgrade a version of Python that might break a different application that expects a different version of Python. So it gets kind of like a rat's nest to kind of manage all this stuff, right? So one of the big benefits of Docker is it solves that problem. Because what Docker does is it provides a standard kind of packaging format that says, I'm going to wrap up all of the dependencies for your application and all of the runtime into a standardized interface. And then rather than running Node or Python or whatever directly on the server, we're going to run it on top of the Docker engine. So now we have a single format with everything inside. This kind of brings us to why Docker is called Docker. So we'll take a step back for a second. If you think about how we ship different goods around the world, right? How we transport stuff, how do we get, cars, animals, toys, computers, cameras, from Japan, the Far East, whatever, all over the world to the US and to Europe and whatever. We don't just throw them on the ships, right? And then throw them on the back of the truck. It's really difficult to like balance it. Everything's going to fall off. We're not going to make efficient use of space. All of the shipping companies and the trucking companies would have to take effect like, oh, well, okay, I need a truck that's capable of carrying cars, and then I need a truck that's capable of kind of optimized to carry this different kind of thing. Instead, we standardized on the idea of a shipping container, right? Shipping companies can, shipping containers are standard sizes. Shipping companies say, okay, my ship carries X number of containers, and I can stack them up. I know exactly what size they're going to be. They probably have weight limits. And cranes are, configured to be able to pull shipping containers off of ships and put them onto trucks. And trucks carry that exact size of a shipping container, right? A train might do the same kind of thing, a freight train. So by standardizing on this kind of packaging mechanism, what the outside looks like, what the interface looks like, we can put anything we want inside, and then we can say to all these shipping companies and trucking companies and train companies, hey, as long as you can deal with and transport shipping containers, this kind of standard interface we've decided upon, then you're great. So this is that's the real life equivalent of what Docker is doing. That's why Docker is called Docker, right? Docker. There's a lot of ecosystem projects around Docker, which are very nautically themed. So you might come across a lot of different tools. They all have this kind of shipping, nautical, whale type theme. So the necessity to run multiple applications, though, is kind of not super new, right? Companies have been running multiple applications for a long time, as you can imagine. But the way people used to do it was to kind of slice up their big physical servers into lots of smaller virtual servers called virtual machines. Again, I might be telling some folks things they already know. But we could say we have this huge, big physical server sitting in a data center somewhere that might have 100 CPU and 500 gigabytes of RAM. And we say, I'm going to split this into 4 smaller machines, each with 25 CPUs and each with, and we do that for various reasons. And then we can install an instance of our application on each one, or multiple instances of each application. Each of these virtual machines are going to have, some of that CPU power and some of that RAM and some of that storage allocated to it. And that was kind of fine. But back in the day, and I'm talking 10, 15 years ago, most applications were pretty huge, right? We'd say they were monolithic. Lots of applications, all the processing logic for all of the things they had to do, all of the business logic was in one huge application. And if we wanted to change one piece of that application, we have to pull the source code for the whole thing. We'd have to change one thing. We'd have to recompile or rebuild the whole thing. We'd have to push the whole thing back onto the server. We'd have to run it, see if it worked. It's just kind of an inefficient way of working. And over the last 10 years or so, there's been a rise in this new kind of design or architecture paradigm called microservices. And that's kind of what you're doing right now, right? Because you've kind of come in at the mid, I won't say mid tail end, right? Because it's going to keep on going, but kind of coming a little bit after. And that's the idea that companies have split their applications into smaller services and APIs, right? The rise of this kind of web-based API, REST API. And it makes it kind of easier to refactor and replace and work on those pieces of functionality. So if you think about the kind of work you've been doing, things like car sales or whatever, maybe different domains. You might have a billing set of services, an account set of services, and a set of services around, user management and administration and offices, whatever. They might be different routers in Node. They might even be completely different services in Node. Back in the day, that would all just be one big bundle of mud, right? We'd all just deploy it to the server at once. There might be a million lines of code, very difficult to change. But we can encapsulate that functionality in smaller APIs now, and we can deploy them as smaller pieces. So this means that application sizes went down, but the quantity of them went up. So now running an application per one of these virtual machines was now quite a lot of overhead, right? Because when we could carve out one machine and we could put this huge, big application on it, it was kind of using most of the power and most of the storage of that machine. Now we've carved our applications into very small pieces. We don't just want to put one of them on a virtual machine anymore, because each virtual machine we create has to have its own operating system and its own kernel underneath. And the kernel is kind of just like the guts or the brains of the operating system. How do we write files? How do we talk over the network? How do we deal with storage? All of that kind of thing. So again, I might be telling people things they already know here with the operating system and the kernel. If you're using Windows, obviously, or Mac, I use Linux. In the enterprise world, Linux is the most popular, really, for servers. I'm just kind of built for that. So how do we get down with this overhead? We now have way more applications or application instances, but they're smaller. So we want to try and kind of pack as many as we can on a single server. We don't want to have the overhead of an operating system each time. However, like I said at the beginning, the downside of doing that without a technology like Docker is we now have dependencies which could kind of cross-pollinate, could cause issues. One application could cause issues for another application. If we can't limit how much resource each of those application instances use when they're sharing a machine, you could get one application taking away memory or CPU that another application needs, what we call kind of the noisy neighbor problem. So Docker came along at the perfect time, really. And what it is that standard format, which is like a Docker container or a Docker image, and then also the Docker engine, which runs on the operating system and gives the interface to run those containers on top of. So now we go away from the world where, I have a server administrator who goes to a server and, they say to the developers, hey, what apps do you want to run on the server? Okay, well, you need to install Node, you need to install Java, you need to install Python, these specific versions, all of these different dependencies, that all goes away now. We can encapsulate all of those dependencies and runtimes into a Docker container, right? So we create a Node Docker container that has Node, the runtime inside of it, all of the dependencies you need for your application. And as long as that server where we want to run your application has the Docker engine installed, we can tell Docker, hey, run this container. And it's going to take care of all the rest of the stuff for us. And this is kind of similar in workflow or user experience that you probably saw already with Heroku. Heroku is kind of easy, right? You just tell it, here's my code, just go run it. But you have to do a little bit of setup. You have to tell it, hey, this is a Node application. And in some cases, it's smart enough to work that out, right? If it pulls out the package.json, or if it's for Python, requirements.txt, which is kind of the package.json of Python, then it can pull that out and decipher it, but you still might need to give it extra instructions to build. So Docker came along at this kind of perfect time. And the reason it came along at the perfect time, as well as the stuff I talked about before, was that the technology that Docker uses actually allows you to share the underlying kernel and operating system while still allowing applications to run in a kind of isolated way. So before, we had to have a new instance of the operating system, a new instance of the kernel with each virtual machine, with each application instance. Now we can run many, many, many application instances on the same machine, and they can share the operating system and the kernel and the resources. So a huge efficiency boost there. But we can also isolate them to a certain degree to make sure that they're kind of like, secure from each other. They can't see each other's memory. They can't see each other's storage. I won't get too much into the detail of how that happens. It's kind of a bit deep in the weeds of like Linux internals. There's plenty of information out there if you're interested, but basically the high level is allows you to share the operating system and the kernel, but maintain some isolation or separation. So I want to stop talking for a little bit and I'll show like a quick demo of what I'm talking about here. So on the left-hand side, I just pulled one of your projects. I think this is one of the Node APIs from last week. And the things I just want to draw attention to is we're listening on port 8000. We'll get this environment variable stuff going on here, but we're going to listen on port 8000 because I don't have this environment variable set. It's going to be our default. And I have Docker installed on this machine. So what I need to do to tell, as well as just running containers, the Docker engine is able to build containers as well, build images that I can then push up to a central place and I can have someone else pull them down. Or I can push up to my server and then have the server run them. So Docker is capable of building them. And to build them, I need to create a file called a Docker file inside my code directory. So I've already created a Docker file here. And I'll just briefly talk through what these commands do, but you can see it's pretty straightforward. This from is saying, which base Docker image do I want to build on top of? So one of the cool things about Docker is it's very layer-based. So you can, again, this is really good for caching and efficiency. If you have multiple apps that build on a Node base, for instance, so I might need Node and NPM and Yarn and a bunch of other things, but not my application, I can pull down a Node base and then I can just build all of my applications on top of this Node base. And Docker will just reuse that base layer as many times as it needs to without duplicating it. So it can kind of safely share that between applications. If you have multiple Python applications, you can pull down an image which has the Python runtime, or the Python interpreter, with a bunch of base libraries. And then you can use that as a basis for building many more applications on top without having to duplicate all of those. So imagine if you had a base set of modules you need to use for Node, how powerful that would be to not have to keep pulling the same Node modules down into each different project that you have. You could just say, hey, start with this base with these common set of Node modules already installed and just share that. And now I don't have to duplicate any of that space. So this is like the base Node image, and I've put this URL in here because all of these images are stored by default in the Docker Hub library. So I can show you my browser here. Maybe. Oh, maybe not. All right, fine. We'll go to that in a sec. But there's a hub online, which is kind of just like a registry of packages, very similar to npm.js, where you can see all of these images. And there's millions and millions of images at this point for all different kind of languages, for all different kinds of pieces of software. I know you've been looking at Postgres DB recently. There are lots and lots of official images for Postgres. So instead of downloading it to your machine, having to configure it, you can just say Docker run Postgres this version, and it's going to pull down that image and run it for you without installing or leaving any of that stuff on your machine. It's just going to keep it self-contained. So what I'm going to say in this Docker file is I'm going to say set my working directories to be /app inside this Docker container. I'm going to install a few tools. So run is basically saying, when you go into your shell and you do, run a command, that's exactly what this is saying. So I'm saying, and this is kind of like brew. APK is kind of like brew for this Linux distribution. On a Mac or on Windows, if you install something like it's Chocolatey or Nougat or something like that on Windows. I'm going to say add Python, add make, and add a bunch of compiler stuff that I need to compile some Node stuff in npm. Then I'm going to copy my package lock and package JSON files into this container. Then I'm going to run npm install, right? So these should be steps that are fairly familiar. Then I'm going to copy, and these copy commands are the thing outside the container and then space the thing inside the container. So I'm going to copy dot. So dot is the current directory, right? So I'm going to copy everything in this current directory I'm in into my container at dot, right? So the current directory outside, copy it into the current directory I'm in inside, and then run this command. So don't worry too much about this tiny thing. It's a little wrapper around Node so that Node handles quit signals correctly. But basically, this is the bit you care about, and this shouldn't be new, right? We're going to run Node, and we say run index.js. And then, as I said, index.js is going to just run this Node API on port 8000. And to build that, I'm in this directory down here. Yep. So I can do docker build. I give it a tag. So -t is the tag that I'm going to give it. So I'm going to actually, when I build this, I'm going to push this image up to my registry in Docker Hub. So if anyone wants to pull it down and play with it, they can. So my account on Docker Hub is John Harris 85. And then I'm going to call this node testing, and I'm going to give it a version 1.0. And then I just tell it where the Docker file is. And it's in this directory, so I'm going to do doc. So I've built this before, so it's super, super quick. What it's going to do is go through all of these steps. So each of these lines here is a step. And if I had cleared the cache here, what it would have done is you've seen the output from npm install, right? All the stuff it would have done on your machine in your terminal, it would have gone through all that output and output that here, exactly like it was installing it on your machine, except what it's actually doing is installing it into this kind of self-contained image, which you can kind of think of a little bit like a zip file or a tar file, right? If you use zips or tars, it's kind of keeping it self-contained. Now what I can do is, instead of, if I was going to normally run this with Node on my machine, right, I could type node index.js, but now I'm going to run it using Docker. So I'm going to do docker run. I'm going to give it a couple of flags. So -t is to say, give it a terminal, right? So basically I just want it to, all of the output that it would normally print to the screen, I want it to forward it back to my terminal here so I can see it. I makes it interactive. So when I want to quit it, I can do Control-C to kill the process. Then by default, when I create a new container, it's going to have its own networking configuration. So I need to tell it, in this case, if we look at my index.js, I need to tell it that, hey, I need access somehow to port 8000 inside my container, right? Because now my container is not the same networking stack. It's not the same set of ports and interfaces that exist on my laptop here. So I have to forward the port 8,000 in the container kind of back out to my machine. Now, the cool thing about this is I can forward that to any port. I don't need it to be 8,000. So this configurability inside the container now doesn't matter so much, because I can have it run on 8,000 inside the container anywhere I want. Because if I'm running it with Docker, I can always configure what the host port is going to be that forwards to 8,000 in the container. So I could choose 9,000 on my laptop to forward to 8,000 inside the container. I do -p, tell it ports. I can specify multiple ports here, but obviously I'm only exposing one in my Node application. And then I just need to give the name of the image that I want to run. So, which is this one down here, John Harris Node Testing v1.0, and I can just hit enter. And we can see that the output here that would have previously just gone to my terminal is now coming down here, right? Because I forwarded the output. So now I haven't run Node, but it's telling my API is running, except it's now not running on 8,000 because I've told it, hey, port 8,000 inside the container where you're running. The way that you need to get to it from outside the container is by going to port 9,000. So let me see if I can bring up a new browser window. Just find my... Try and find the right browser. There we go. You see new tab. So now if I go localhost, you see this?
Yes.
9,000, I get the API response. So I haven't run anything directly in Node. I've now just run my Docker container, but it knows how to run that command under the hood. And actually it's not running at 8,000, it's running at 9,000 because that's where I mounted my port across. So this is pretty powerful, right? Like let's say you're working on 5 different projects at the same time, but the port's always hard-coded to 5,000 in all of your projects. If you run it through Docker, you could say, hey, run project 1, but forward 5,001 on my local host to be 5,000 in the container, 5,002 for project 2 to 5,000 in the container, 3, and so on and so on. So you don't need to go in and tweak the port inside. You can actually just tweak it using Docker, and you can forward the ports to different containers. So that's pretty powerful. This is kind of only just scratching the surface, obviously. You know, running one instance of an application in a container is great. You have to worry about things like, what if the container dies? Or how do I talk across the network to other instances of other applications, different backends, different services? How do I make sure that they're being health checked correctly? You know, if one fails, how do I restart it? If a server dies, right? Like it happens, right? Servers die, Amazon Web Services die, Heroku has outages, these services have issues. If it goes down, how do I automatically migrate it to other services? And that's where we kind of get a layer above Docker to something like a container orchestrator, which is something that controls and moves around, monitors and configures multiple containers or multiple hundreds, thousands, or millions of containers. And that's kind of the area that I work in a lot now. The main tool to do that is called Kubernetes. If you're interested, you can go look it up. There's plenty of material on it. So yeah, this is just a super basic kind of scratch of the surface. If we go back and I just show pushing up that image as well to the hub, and you can see what that looks like. Where's my... So I can hit Control-C here. And now if I do a Docker push, I can push up this image. It's going to push up all of these layers, right? So it pushes these layers up separately that are in the Docker file. And again, it can reuse, because these layers are read-only, it can reuse these layers across different pulls. So it's kind of optimized for efficiency at lots of different levels. Might take a second to push some of this stuff up, might be big. But basically what I can do once I've pushed this up is I can give anyone access to this image. I can say, hey, you can just go do Docker pull now instead of push. Pull this, you know, much like you're doing a git pull of a certain repo, right, or a clone of a certain repo link. You could pull this, and if you have the Docker daemon or the Docker runtime running on your machine, You can just go do Docker pull on this image, Docker run, give it, again, any port that you want, and you'd have my application running on your machine. So again, it's kind of a powerful, it's not used too much to share applications between developers, because obviously GitHub is a better way of doing that. We want to share code with other developers. But if you think about sharing this and having automated systems that pull down Docker images and run them on our servers in production for kind of customer access, then that's pretty powerful. We don't have to do builds, all of that's done for us, all of the size is optimized, the layers are all cached and optimized, and then we can kind of set it up how we want. So that was kind of a super whistle-stop tour. I hope that was kind of semi-useful as to why this is. There's lots of material around Docker. Docker's been an insanely popular technology over the last 5 years since it really was invented, maybe 6 years now. There's loads of introductory material, and the ecosystem is pretty big. I wouldn't say it's a must-have as kind of a new developer just coming into the space, but you can certainly differentiate yourself if you're interested and you want to learn it. Certainly lots of jobs are going to be looking for, Docker skills or containerization skills or Kubernetes skills, especially if you go down that full stack route. I'll open it up for questions.
Yeah, I've got one because I'm brand new to Docker. Do you install this as like an NPM package initially, as like NPM install Docker to get it on your machine, like a global install, or is there like a website you go to download it?
Yeah, it's a binary for, it's not an NPM package, it's written in Go, the Go language from Google, but it installs just as a binary. So if you go to the page, I think it's just docker.io, and then click download, there's downloads for Windows, OS X, Linux, all different kinds of operating systems, and then it will just install it globally as a tool, and then you just go Docker on your command line, yeah.
Okay, cool. And one other one, the Docker file, is that automatically generated by Docker, like some kind of Docker init, or do you actually physically type out and create that Docker file without an extension on the end of it?
Yeah, you physically type out and create that. By the way, the convention is it's called Dockerfile. If I want to call it something different, I can. But when I run Docker build, I need to specify a -f flag and tell it where I want it to be. So if I don't specify a -f, it's going to look for a file called Dockerfile. If I specify the -f, I can call it anything I want. But yeah, you would write that yourself, because this is basically the instructions of you telling Docker, how do I build my application? Right? And most of the time, it might just be for Node, right? It might even just be this simple, right? It might just be like, copy my package.json, run an npm install, copy my actual source code in, and then just run like node index.js. And there's plenty of examples of, how to optimize Docker files. And if you just typed into Google, best practice Node.js Docker file, then it would just give you a whole bunch of examples, I guess you could just tweak.
Cool. That's about all I had. Anybody else got any questions?
No, none from me, but thank you.
Nope. I have no questions either.
Yeah, I'm just curious to get trying it. Thanks so much for the showcase.
No worries. I'll send over some links. When I was at Docker, I created some training material, and I've created some kind of free video content where I am now that helps intro to this stuff. So I'll send some links through Christina, and she can throw them in Slack or whatever.
Yes, definitely. Awesome. And thank you so much, John, for doing this. This is really cool. Thank you.
No worries. Have a good one.
All right, you too.
Thanks. Bye.